Go ahead and resume where we left off on this problem with all this lovely cross simplifying, which leads us to our final equation in standard form of x minus 3 squared over 4 plus y plus 1 squared over 25 equals 1. I would put an important box around that equals 1. That was an issue on the Unit 2 test, was remembering to write it as an equation and not leaving off that equals 1 at the end. Also remembering to put in the little square. Sometimes that little detail gets missed as well. So that is our equation in standard form. And what standard form is useful for is pulling out all of the key features of that conic section. Before we get into that for ellipses though, I want to turn you loose on this problem. So see if you can complete the square with that hyperbola. Go. Does that negative in front of the y squared count as a coefficient? Yup. So you have to take it out of both the y squared and the positive 4y, which makes it a negative 4y. So make sure you've got that in that step. Go ahead and check yourself. Now we've done 2 problems of completing the square. The only thing that we haven't done is completing the square with a circle. If you have a circle, instead of dividing by the number on the right side, you would divide by the coefficients, which would be the same. That's what's going to get rid of those coefficients and move them to the other side, which is equal to r squared. Yes?
Is like the, so in like the, or you add, okay, so like the middle term, I guess the x term, is it always gonna be like able to be like split into?
cross simplified, like, oh, is the
sorry.
middle term? Yes,
Yeah.
you'll never have any where you have to have fractions.
Okay.
Yep, great question. Yep, you'll always be able to divide it equally into two numbers that are the same, that are not fractions. Good question. Any other questions before we dive into the vocab? Maybe it would be good if we just peeked back in Unit 2 notes at a few things first. First, remember that for conic sections, ellipses and hyperbolas, we can have horizontal or vertical. Horizontal ellipse longer this way, vertical ellipse longer that way. The vertices are always the endpoints of your major axis, which is the longer axis, which indicates the direction. Your A values tell you how far the vertices are. The major axis has a length of 2A. The co-vertices are B units from the center, and the minor axis has a length of 2B. Your foci are C values away from the center, and they are always on the major axis. So if we flip to the hyperbola, we notice some of the awkward similarities. The vertices are still A units from the center, but instead of having a major axis, it has a transverse axis connecting the vertices. And that's because in a hyperbola, the transverse axis is not necessarily the bigger or the longer axis. So major indicates larger, transverse is just another fancy word for it connects the axis between the vertices. Conjugate axis is 2B. We don't really care about that one, connecting the endpoints because it's not really part of the graph. And then our hyperbolas also have asymptotes. So let's see what we can figure out about the center of each of these. Your center comes from the equation, and it is your H and K value. The only thing tricky about the center for all three conic sections is switching the signs. So your H term comes from the X parenthesis. So if it's a -3 in the equation, it's a +3 in the parentheses. And if it's a +1 with the Y in the equation, it will be a -1 in parentheses. Then what about for a hyperbola? Bless you. See if you can write the center for the hyperbola. Should be -1, 2. And that's going to be the same if you had the equation of a circle as well. So finding the center, same for both of them. So let's go ahead and see if we can determine horizontal or vertical. I would say that this is one of the most important boxes because if you mix up the orientation of the conic section, everything else kind of goes berserk. So knowing how to figure this out is vital for the rest of the problem. So first, we determine our orientation from the A value. For ellipses, A is always, can anyone complete that phrase? Close. For an ellipse, A is always bigger. So that bigger A value, the major axis, A is always bigger for an ellipse. So in your equations, remember that you are always given your squared values. I'm going to flip back to that big chart again. So in all the conic sections, we've got A squared, B squared, B squared, A squared. Even in a circle, we've got R squared. So your variables in the equation are always squared, but when we pull those out to use them for graphing, we always use the non-squared version. So for this one, which of these, bless you, corresponds to A squared, the 4 or the 25? The 25, because it is bigger. So 25 corresponds to A squared. So what is A equal to? 5. That means the 4 corresponds to b squared. So our b value is 2. Now for a hyperbola, a is always first. This is one of the most common errors made on the Unit 2 test, so it's going to remain one of the more common errors on the final. Because if we can't keep these straight, we're going to look at this hyperbola and go, my a value is 4. But what is my a value for this one? 2. So since a is always first, that means the 4 corresponds to a squared, and the 16 corresponds to b squared. So a is 2, b is 4. So we figured out a lot of the key pieces, but we still haven't said whether these are horizontal or vertical. We use our a value to determine this because it's whatever variable my a value is under that determines the orientation. So here, my a value is under y, so this would be vertical. Here, my a value is under x, so this would be horizontal. Now, the c value. What does the c value tell us again? Tells us how far the foci are from the center.